Section 9-3, rotations. A rotation is a rigid motion that turns a figure about a fixed point called the center of rotation. So here we have the origin is the center of rotation. This is rotating around the origin. The angle of rotation is the number of degrees the figure rotates. The angle of rotation is the number of degrees the figure rotates. Now, rotating a complete circle would be a rotation of 360 degrees. Remember, a circle has 360 degrees. Half a circle would be a half of 360, which would be 180, okay? So remember, a circle is 360 degrees. A semicircle, which is half a circle, would be 180 degrees. So from here all the way around to here would be 180. From here all the way around back to where you started would be 360, all right? A positive angle of rotation turns the figure counterclockwise. So think of what counterclockwise is. Think of your clock. It's counterclockwise. That means it goes to the left. So going to the left is counterclockwise. All right, going to the left is counterclockwise. Yet you would have a positive angle if you go counterclockwise. If you go to the right, like a normal clock hand would, that's going to be clockwise. Okay, and that would be a negative angle. Okay, all right. So let's look at part 1. Recognizing rotations. Identify which transformation is a rotation. Using a rotation of the origin. Using the rotation of the origin. All right, think of this triangle here. All right, which one of these 3 graphs is an example of a rotation? Now, think about me taking this triangle and rotating it around. Rotating it around, coming all the way around with it, rotating it around, all the way around the origin. Do my letters pair up? Think about me rotating that triangle all the way around, positive counterclockwise. If I rotate it around, does my A, is it matching A prime, B matching B prime, C matching C prime? Yes. So ends up the first one that we chose here, this one is our answer. Okay? We were able to take this triangle, rotate it around. I'll do that again. We started here. I started out with ABC. As I rotate this triangle around the origin, rotating it around, bringing it, just like you're bringing it all the way around here. You see me transforming it. And when I brought it all the way around a rotation, the A, B, C paired up. Okay, so this one is the correct answer. This is a rotation around the origin. All right, let's try this one. Let's see if it matches up. It's not going to, but I want to show you how I know this is not the correct answer. So if I take this one and I bring it all the way around, you got to turn your triangle, bringing it all the way around. Look at how it lands up. Okay? You see A does not match A prime. It's matching C prime. Okay? And this one would be our A prime here. So you see that this triangle does not match up with the letters. Okay? So this one is not a rotation. All right, let's look at this one. Looking at this one here. Here we are. I've matched them up to begin with A, B, and C. Okay? If I rotate this one around the origin, think about it, rotating it all the way around the origin. Okay? Does it pair up? See, B is supposed to be your point. B has to be the one closest to the origin, like it is here. I'll do that again. See, B is closest here. If I rotate it around, B's closest there, B's closest there. And when I come on around, B has to be the closest one here. So is B the closest one just like A is? Is B matching up here just like B is here? It is not. So you see, this is not a rotation, all right? So if B is closest to the origin here, B stays closest all the way around, and y'all should have B prime, okay? And so forth. They should all match up, all right? So ends up, my correct answer for part 1 is this graph, the first one.